Okay, so ladies and gentlemen, as we're looking at all of these problems moving forward where we need to simplify these exponents, my piece of advice to every single person is that you need to use a piece of paper. You need to write these out on paper and go step by step, writing out every single step that you do. Because if you're just doing it all in your head, you're gonna mess it up. So let's take a look at the first one on slide number 19. So if we look at it, it says 6x to the 7th divided by 2x to the half, right? So we know if we think back to slide number 18 on this lesson, you have to do to the coefficients, those numbers in front of your x's, exactly what the operation is telling you. So since this is a fraction, this tells us that we need to divide. So that means we need to divide 6 by 2. When we do that, we get a 3. Okay, and then we need to think back to slide number 15 where we had these division rules with exponents. So we have an x to the 7th and x to the 2nd. And if we look back to that, when we have dividing of exponents like this, we need to subtract, keep my base the same, and subtract my exponents. So I need to do 7 minus 2. So I'm going to be left with my base of x and to the 5th power. Okay, so that's how we go about doing that one. We do to the coefficients exactly what the operation tells us to do to get the 3, and then you subtract your exponents. Okay, let's take a look at number 2. This one's probably the simplest of the 6 on this slide. We need to, like I said before, you need to do to these leading coefficients exactly what this sign is telling us. So if it tells us that we need to, one moment. If it tells us that we need to multiply, we have to multiply 2 times 4 to get, or 2 times 2 to get 4. And then when I look at, and I think back to my rules, since this is multiplication, I need to add my exponents. So that means I'm going to be left with my base that's the same, an x, and I have to add my exponents, 5, 6, 7. 4 to the 7th power. Okay, let's take a look at the next one. Okay, number 3. Okay, this guy here, because this raised to the 3rd power is outside my parentheses, I need to distribute it to both parts here. I need to raise the first piece to the 3rd power. I need to raise my second piece, my variable, to the 2nd power to the 3rd power. So first, I need to do 3 to the 3rd power. And we're going to say m to the 2nd times, because it's outside, we need to multiply by 3. Okay? So when I do 3 to the 3rd power, I get 27. And then when I multiply 2 times my 3, I keep my base of m, multiply 2 times 3 to the 6th power. Remember, if you're typing it into your calculator, you need to type it like this: 27m to the caret 6. Okay? Let's take a look at this next one here, number 4. Okay, this one is probably the most challenging of all 6 of these. So paying really close attention, making sure that you're using a piece of paper, because this guy here is a 2-step problem. You need to do it in the correct order using PEMDAS. So if I have my parentheses first with an exponent on the outside. So just like I said here, I need to take this exponent here and I need to distribute it to all 3 parts. I need to take this raised to the 4th and distribute it to my 2. I need to take my to the 4th, I need to distribute it to my c, and I need to distribute it to my, I'm going to use a different color so that we can really tell the difference. Raise my 4 to the 4th power to this d to the 2nd. The c and the d are separate because they're 2 different variables. So that means I need to raise each part separately to the 4th power. So when I do it, I have to raise 2 to the 4th power. So that means 2 to the 4th power. I need to raise c to the 4th power. I need to raise d, that's already to the second, to the fourth. So when it's outside parentheses like this, that means we're multiplying. So we're going to have to multiply my two exponents here. When I type, this is correct. This 2 to the fourth is correct, but you need to simplify it. So that means in your calculator, you need to put 2 to the fourth, which when you do that, it gets you 16. And then we have c to the fourth because c was originally to the first, so 1 times 4 gets me 4. And then I have d, and I need to multiply my exponents here. 2 times 4 is 8, okay? So then I need to bring down this piece that I didn't do anything with, times c to the fifth, d to the fifth, okay? So I have this left over. This first piece has a leading coefficient of 16. This guy over here has a leading coefficient of nothing, which we can imply is 1. So we would multiply our leading coefficients because remember, we do the operation with the leading coefficient. So 16 times 1 gets me 16. Now I have to multiply these c's, so that means I need to add my exponents. So I'm going to have my base of c, and I have to add 4 plus 5 to get me 9. Make that more like a 9. And my d, I also have to multiply, so I'm going to add my exponents again. I'm going to say d to the 8, 9, 10, 11, 12, 13. Okay? Look at this guy right here. It's a two-step problem. You need to make sure that as you're going through this, you are using paper. Paper is going to be very important. Okay, so let's take a look at number 5. I missed one little piece here. This top is in parentheses. If we use this idea of PEMDAS again, okay, you always need to use your order of operations here. Because this numerator is in parentheses, first thing you need to do is you need to multiply these two here. So when you multiply, you have to actually do what the operation is telling you with the leading coefficients. So I need to multiply 5 times 2 to get me a 10. And now because we're multiplying, I need to add my my exponents, sorry. I keep my base of 10 and I add my exponents, set 3, 4, 5, 6, 7. And I bring my denominator down because I didn't do anything with it. 10 to the k to the 8, 10k to the 8, okay? So I have this right here. Very good. So now I need to do to the leading coefficients what the operation is telling us to do. So I have a 10 divided by, because a fraction tells us we need to divide, 10 divided by 10 gets me a 1, right? And now I need to subtract my exponents here because this is division, so we need to subtract them. I have 7 minus 8 gets me a k to the negative first. Ooh, geez. Okay. Well, if I think back to slide 16, I can't have a negative exponent like this. So I'm going to have to come down below here, and I'm going to have to rewrite this in a form that's appropriate because this negative 1 up here is not appropriate. So remember, when we have a negative exponent here, we take this and we sort of reciprocate it because this is written as 1k to the negative first over 1. All fractions, all whole numbers can be written as over 1. So now we need to reciprocate or flip, inverse that fraction. So our 1 is going to come up top, and we're going to bring that k down to our denominator. And remember, when we reciprocate or inverse that fraction, that negative 1 is going to turn into a positive 1. So it's 1 over k to the first power, or you could just simplify it as 1 over k. Remember, if you're writing it in the calculator or when you're typing it in, if you can't create a fraction, you're going to write it as 1 divided by k. Okay? Wonderful. Let's take a look at the last one. We have to do to it what the leading coefficients, what the operation tells us. So we need to divide 3 by 12, and that gets me 1 over 4. okay? Because you simplify, divide by 3, you get 1, you get 4, okay? So now we need to subtract our exponents here. 2 minus 6 gets me a negative 4, so I write the x to the 4th in the denominator, because remember we said it was going to be x to the negative 4th, right? And we can write that as 1 over x to the 4th. So this x to the 4th gets moved down to our denominator, and when we subtract 3 minus 3, we get 0. We would say y to the 0, which is the same as cancels out. Well, it's equal to 1. So we can write this as 1 over 4x to the 4th, or if you're typing it in your boxes, you're going to type it as 1 divided by 4x caret 4. Okay? So that's slide number 19 for all those people that have struggled with it that still didn't get it the second time around.